Hello everyone, welcome to the solution of LeetCode problem 1462 named course schedule 4. In this problem, there are total n number of courses you have to take which are labeled from n-1. Let's consider num courses is equal to n. Now, you are given an array of prerequisites where prerequisites of I is equal to A of I and B of I indicates that you must take course A first if you want to take the course B. For example, the pair 01 indicates that you have to take course 0 before you can take course 1. Now, the prerequisites can also be indirect. That means if a course A is prerequisite of course B and course B is a prerequisite of course C, so here we can say that course A is also a prerequisite of course C. Now, you are also given an array queries where queries of j is equal to u of j and v of j. That means for the jth query, you have to answer whether course u is the prerequisite of the course v or not. If the course u is the prerequisite of the course v, we have to return true, otherwise we have to return false. Now, we have to return a Boolean array answer where the answer of j is the answer to the jth query. Now here, let's consider this third example. 1 is a prerequisite of 0, 1 is a prerequisite of 2, and 2 is a prerequisite of 0 also. So here we have to determine whether 1 is a prerequisite of 0 or not. Yes, 1 is a prerequisite of 0, so we have to return true. And we have to determine whether 1 is a prerequisite of 2 or not. Yes, 1 is a prerequisite of 2, so we have to again return true as well. So the final answer vector will contain two elements, which is true and true. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. Now here, this is a really pretty big graph. Suppose for the node 7, this is the course 7, it has the prerequisite 2, 3, 1, and 0. Because to complete the course 7, we have to complete these 4 courses as well. Now, suppose we have to determine whether one course is a prerequisite of another or not. Suppose we have to determine whether 1 is the prerequisite of 7 or not. How can we determine it? We can simply look after all of the ancestor of the node 7, and if we find 1 in all of the ancestor of the node 7, we can say that the course 7 is dependent on the course 1. So here, basically, we have to deal with the ancestors, and for each of the node, we have to find the ancestors to determine which course is presented on which course or not. Now, how can we find all of the ancestors? So here at first, this is a classic graph problem, and in which graph algorithm we should use to solve it. So the first intuition comes into our mind is that if any kind of graph we have to deal with the dependencies, we will use the topological sort to solve this problem. And to implement the topological sort, we will use the Kahn's algorithm. Now here, by using the Kahn's algorithm, we will find all of the ancestors of each of the node, and by determining the ancestors, we will check which course is dependent on which other or not. So here, at first, to implement the Kahn's algorithm, we have to run a BFS on which node which has the in degree of 0. Now, why we are taking in degree of 0? Because if any node has in degree of 0, those node is not dependent on any other. That means no other connection is coming towards this node. So here, there are 3 nodes which has the in degree 0, which is 0, 1, and 2. So to implement the BFS, we have to take a queue and we will insert 0, 1, and 2 here. Now what is the top element of the queue? It is 0. So we have to remove 0. After that, we have to remove the outgoing edges from 0. So we have to remove 0, 4 and 0, 3. Now, 0 does not have any of the dependencies, so we don't have to push anything into the index number of 0. Similarly, our current element is 1. So we have to remove the edge going out from 1. And as 1 does not have any of the dependencies, so we have to push nothing into the index number of 1. Now here, our top element is 2. So we have to remove the node or the edges coming from the 2. But 2 does not have any of the dependencies, so we don't have to put anything into the index number of 2. Now, this node 3, this node 4, and basically these 2 nodes has in degree of 0 because the nodes coming towards them is vanished now. So we have to insert 3 and 4 into the queue. Now our top element of the queue is 3. So what are the ancestors does these 3 have? There are 2 ancestors, which is 0 and 1. So we have to put 0 and 1 here. Now we have to discard the edges coming from the 3. Now our top element of the queue is 4. So what are the ancestor of the 4? It is 0 and 2. That means to complete the course 4, we have to complete the course 0 and 2 first. And after that, we have to discard the outgoing edge from 4. Now, the top element is, or the element which has the in degree of 0 is 5, 6, and 7. So we will insert 5 here, 6 here, 7 here. Now, the top element of the queue is 5. So here, 5 is dependent on the 3. So we have to put 3 here. Now, as node 0 and 1 is dependent on the 3, or we can say that 3 is dependent on the node 0 and 1. So we can say that 5 will also dependent on the node 0 and 1. So this is the indirect relationship on the dependencies. So we have to insert the dependencies of the 3 here as well. So the dependencies of the 3 will be 0 and 1. Now we are at this element 6. So what are the direct dependencies of the 6? It is 3 and 4. So we will insert 3 and 4 here. And we have to also insert the dependencies of 3 and 4 here as well. So the dependencies of 3 will be 0 and 1. And the dependencies of 4 will be 0 and 2. So 0 already presented here, so we will insert only 2. That means 6 is dependent on this 5 node. Now we are at this point 7. So here 7 is directly dependent on 3 and 2. So we will insert 3 and 2. Now we have to insert all of the dependencies of 3 and 2 as well. So 3 has the dependencies of 0 and 1. That means 7 will also dependent on the node 0 and 1 via indirect dependency relationship. So here, this is our dependency calculation. In this matrix, we have calculated in which node is dependent on other. Suppose this node 6 is dependent on this 5 node, which is 3, 4, 0, 1, and 2. Now, we have to find the answer, the dependencies. Suppose we have to find whether 3 is dependent on the 7 or not. So we will simply look after the position 7, whether there is a node equal to 3 or not. Yes, the 7 has the dependency of 3. So here we have to return true. Otherwise, if 3 is not present into the dependency of 7, we have to return false. Suppose we have to determine whether 7 is dependent on the 4 or not. So here we have seen that 4 is not presented into the dependency list of 7. So we can say that 4 is not dependent on the 7, or 7 is not dependent on the 4. This is how basically the Kahn's algorithm works to find the dependencies. I hope you understand it. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named check if prerequisite or not. So here we are given a parameter n, and we are given a list of prerequisites and queries. Now, we are taking a vector to store the in degree, and we are taking an adjacency list, Boolean vector answer, and vector of set ancestors. And to implement the BFS, we are taking a queue. Now, for each of the prerequisites, we have to increase the iterator of 1 to the in degree, and we have to build the graph. That means adjoint of iterator of 0, pushback iterator of 1. Now, for each of the node from 0 to n, if current node has the in degree 0, we have to insert it into the queue to start the BFS. Now, in the BFS, we have to store the current element of the queue into a variable current, and we have to remove it. Now, for each of the child in the adjacency list of current, we have to insert the current element in the ancestor list of child, and we have to insert the ancestors of current element in the ancestors of child. After that, we have to decrement the in degree of child, and if the in degree of child is equal to 0, we have to insert the child into the queue for the next iteration. Now, for each of the queries, if iterator of 0 is presented in the ancestor of iterator of 1, we have to insert true into the answer. That means we have found the dependencies. Otherwise, we have to insert false. Finally, we have to return answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.